Good day, and welcome to the presentation of LITESTAR for the version 602, the brand new version of our lighting design and data management program, management of lighting products at 360 degrees. The new feature that we implemented at the program were basically related to two modules. The first one is photo view, the photometric and the colorimetric data manager. And the second one is LightCalc, the lighting design module. Let's get into details of what was added to the program. So let's start with photo view. So the new features of photo view are save, load, printout configuration in custom print settings, the management of the source currents, the currents that are used to drive the LEDs, the laboratory instrument table, the standards and certainties table, the calculation of the melanopic ratio for the circadian approach of lighting, and the shortcuts. So not only new features were implemented, but especially at photo view, we added some new features in order to manage in a much easier way the program itself. Let's start with the first new feature of photo view. So the user now can save the configuration once defined through the two windows that you see here. I can drag and drop one module, for example. If we are dealing with an indoor luminaire, for example, we want to have general data. So the first page, the second one is the polar diagram. Then we may add the spectrum, the luminance. We may add the UGR table. So you can add whatever you want. The main problem is that photo view can be used with different floodlights, with different road luminaires, and for different indoor luminaires. So for any one, you may have a different set of modules you want to print at your airport. So before, it was quite heavy to define any time what you needed to print. Now you can save it to the configuration. You can save your own configuration, and then you can load the configuration. So once you print the report for the indoor luminaires, then you want to switch to the reports for outdoor luminaires, for road lighting luminaires, for example. You simply select load. This window will appear. You select the one of interest, and the new configuration, the new set of modules to be printed will be displayed here. Next one, LED luminaire source currents. So one of the main issues now characterizing the manufacturers and the people working on design in the market is the management of the driving currents of the LED products, which is now forcing the people to produce, mostly the manufacturers, to produce one file, one IS file, one ULUM.dat file per any different current setting. This is bringing to the creation of many files for the same luminaire, and basically it is absolutely the same photometry, which is only scaled based on the different fluxes characterizing the different current, the different driving currents. So the idea that we had was to develop a module through which we can manage the infinite currents that you can use to drive your product. And this is all stored at the same file, the OXL file. which is the file that Occidental developed starting many years ago, and which can carry many different information related to the same product. In principle, you access the photo view, and through the main window, you can select the flux power in function of current. This window will appear, and through here, this one is the set of current, flux, and power values characterizing the main photometry. But then you can take other values. For example, you leave the luminaire at the goniophotometer, you leave it at gamma 0, for example, and you drive the current to a new value, for example, like in this case at 0.5. You read the value, the lux value at gamma 0, you convert it to intensity, and you create the ratio in between the intensity value at gamma 0 corresponding to 350 milliamps to this one. And the ratio can be applied directly to the flux because it's proportional. You read then the last value directly from your multimeter. The same for the third value. Once you have finished, you select Update, and the program will automatically show you the polygonal, which is the approximation of the curve flux power in function of current. This curve is basically a curve with a concavity in this direction toward the bottom of your diagram, which means that the polygonal is giving you in between the values below the curve, which is a safer condition. It is not exactly the point, it is not exactly the value at the curve, but the difference is really a minimum difference. The instrument table. So, up to now, we have been using files which were characterized by simply the photometry. Only the photometry could be managed and few other information. Nowadays, we are dealing with products characterized by many information. And first of all, probably you would like to know which was the set of instruments that were used at the laboratory to perform the measurement. So we added such a table where you can exactly input the list of instruments that you used for the measurement, for the photometric or for the colorimetric or for the electrical parameter measurements. And first of all, you can also define the calibration expiration date, so a full set of information. Even you can also input the correction factor if you send your instrument to a laboratory and it comes back only giving you a value which you have to apply. The program will automatically apply the correction factors to any of the available parameters. So power, current, the tension, in case of electrical parameters, the photometry, or the spectrum in case of photometry and spectrum measurements. And this is, we can come to the instrument table through the Tools button, which opens this window, and at the bottom left you can find Instrument List. Once you confirm, the list will be merged with the information about the luminaires, and then it can be saved again into the Excel file. At the same level, we developed the same concept also for the standards and for the laboratory uncertainties. The standards, probably it is absolutely necessary to know which was the standard that you applied for your photometric or for your colorimetric measurements. So, for example, if you applied the European standard for LED measurements, or if you applied the IS LM79. And this will be saved again together with the OXL file. The same. The laboratory is characterized with a certain amount of uncertainties, and these uncertainties can be defined through the uncertainty table, which again can be saved at the end within the OXL file. Let's come now to the lighting design module. So we introduced the following features. The first one is the high mast and luminance group features, through which you can manage the high mast, for example, the ones used for the lighting of a stadium, but also for the lighting of a roundabout or for the lighting of the indoors. Whenever you have a luminaire characterized by different luminaires which can be aimed separately, like, for example, the ones that you may have in a shop. Then we added the new definition of the luminance curve for the lighting of tunnels, following the Italian standard 11095 2019, which was published last year. This is method B. So in place of carry on the usage of the CIE 88204 recommendation, in Italy we introduced a brand new standard which is giving you a different approach to the luminance curve at the entrance of the tunnels. Then again, the source current management. Why? Because we gave the option through the PhotoView module to input the current curve, but now through the lighting design module, through LightCalc, it is possible to use the set of values available through the OXL file, for example, to design your road lighting. So more and more it is necessary to give exactly what you need for the lighting of the road. So for example, over here in Italy, over here in Europe, we have the definition of the class, and through the definition of the class, you have the definition of a value, minimum value in terms of luminance. So for example, M3 is 1 candela per square meter. And so when you define your lighting, probably when you use your luminaire at, for example, 500 milliamps, you have that probably at the end of the calculation you can find 1.8 candela per square meter, but you need let's say 1 plus 10%, you need 1.1, and so you are not using the exact amount of energy. You can reduce it, and so through driving the currents, you can reduce, and at the end you can find exactly the right level, the right value of current, which is corresponding perfectly to 1.1 candela per square meter. Then the other feature that we added is described through these three icons. You can duplicate the luminaires along a line, in a circle, or along a curved line. And at the end, the symmetry. The symmetrization function, which is related, for example, to the lighting of a stadium, of a football field, where you have an high mast in one corner and you want to symmetrize. So you want to automatically create the other three high masts, and this should be done in an automatic way. So let's start analyzing more in details the high mast and luminaires groups feature. So as you can see here, through this feature, we can define the number of lines and the number of columns where you want to define the panel. Then, once defined the panel, we can manage the panel and the luminaires at the panel in a dynamic way. So yes, we can leave them per rows and columns, but we also introduce the dynamic way, which means that you can move the luminaires in order to correspond perfectly to the situation you are finding. So for example, an eye master may have different levels, and the luminaires, for example, in the case of asymmetric luminaires, cannot be placed exactly along a panel. Why? Because the luminaires above can be shadowed by the luminaires below. And so you have to move them a little bit farther out so that the light can reach the field. One point. The other point could be, for example, over here in Italy, we have some stadiums where the top of the tribunes, the cover of the tribunes is not flat, but it is a curve. So through this feature, you can exactly place the luminaires wherever you want, and they will be always part of the same group, so you can activate to the group the same configuration. So if you want to turn the high mast off, you can do it straight away, because the options can be applied to all the luminaires belonging to the same group. Another feature is that over here you have the example of a aiming. The aiming is characterized by a line, and this line ends with an arrow. So you can activate the aiming simply by clicking at the arrow. It is not necessary, like before, to select the luminaires and then come down to find the arrow and to find the aiming. It is automatically activated through here. The other feature that we introduce is that you can group the luminaires, and per any group you can give a different color. As you can see here, there is a one color for one group, which is the blue one, and the other one is characterized with the orange color. This is the part related to tunnel lighting. We added over here the brand new standard where, as you can see here, the curve is no more similar to the luminance curve characterized by CIE 204, CIE 88204, where you have at the beginning, for the 50% of the stopping distance, you have a constant luminance level, and then it goes down up to the transition zone. In here, in Italy now, we have, following method B, we have a curve which is going down straight away, always ending at the stopping distance, where at the stopping distance we have the beginning of the transition curve, which will be then ended at the beginning of the interior zone. As you can see, there is a big difference in between the tunnel approach and the CIE 88 approach. This was based on the study of some professors over here, and it is widely adopted by the companies managing the tunnels at the freeways over here in Italy. As you know, we have a country based on approximately two-fifths of the country is mountain, and so the tunnels are above. In this case, they started away in order to have a less level of energy to be used at the tunnels placed high at the mountains. Duplication. Duplication, we can have a rectilinear line, curved line, and circle. It is done, we developed a set of features that are very easy to be used because they are mostly used graphically. You don't have to input many values. and simply defining the radius or defining the diameter in case of a circle will appear at the end once confirmed the diameter, and you can move the circle in order, for example, to correspond perfectly to the roundabout you are studying. Or, for example, if you have a road with a curve, you can follow exactly the curve, and once you confirm, the program will ask you how many luminaires you want to place, and automatically, once confirmed, the program will display the luminaires at the curve. Symmetry. If we deal with the lighting of a football field, we have the definition of the main eye mast. We call it the mother eye mast. And then you want to symmetrize in order to use the same aimings also for the other eye mast. And this is done through the symmetry, to the symmetrization feature that can be activated through this icon, which allows you to open this window where you have to define the center of symmetrization. In this case, 0, 0 correspond to the center of the football field. And then the plane of symmetry. You have two different, let's say three different options. The first one is a single plane, which can be vertical plane, through which you can, from here, symmetrize and create the one at your right. If you use horizontal, then it will be created this one. If you select the vertical and horizontal, automatically the program will symmetrize following two different planes, creating other three eye masts. As you can see, once you symmetrize the eye mast, you symmetrize the panels, but you also symmetrize the aimings. Thank you.